So hey guys, today I want to talk about motion profile. So this is one of those things that you should know when you're doing robotic, this kind of things. And if you are interested in this topic, you are in the right person because I'm playing with motion profiles for almost 9 years now, more than 9 years actually. So I did a lot of motion. I developed a lot of motion profile. I use a lot of motion profile from different vendors and suppliers. So I'm very familiar with the subject, and to be honest, I don't know many people that they know motion profile as well as I do. Okay. So before we start, the first question is that why we need the motion profile in the first place. So the reason that you need a motion profile is just imagine you driving a car. Okay. So you want to go from the zero, a starting point to the end point. Okay. You just cannot to accelerate. You cannot to just put your leg on the acceleration pedal to the maximum at the beginning, and after that when you reach to the destination immediately take out your leg out of the acceleration pedal, right? So it would be a very horrible movement. Okay, so this is a very bad idea. So this is the reason that we need a motion profile. So how the motion profile works, actually in our head, we usually do the motion profile. Okay, so without even knowing it. For example, in a driving case scenario, what you will do is that when you are starting your destination at the beginning, you slowly accelerate. So because you want a smooth motion, right? So you don't want to suddenly put your leg fully on the acceleration pedal, right? So you slowly accelerate, so increase the velocity. Okay. After that, you will when you are on the road, when you are on the highway, you will maintain your speed at a certain speed, for example 100 kilometer or whatever the limitation of that um, road it is. And when you get near to the destination, you slowly decrease your speed by putting on the brake pedal, right? So yeah, so this is exactly the job of the motion profile. So this is the very basic motion profile. So if I want to put this one in the graph, so this one it is destination zero, and this one is on the location zero, and this one is on your target destination. Okay, so this is the way that you are going to the path. So let's see in terms of velocity. At the beginning, when you start the journey, okay, you slowly increase your velocity. After that, when you are on the highway, you maintain your velocity, and when you get near to the destination, you start to reduce your velocity. So very simple. So if you look at it, okay, so if you do the differential of this one, it means that you look at it in terms of the acceleration. So, acceleration in reality is exactly like acceleration pedal. Okay, so gas pedal or something, whatever you are calling it. So, for example, at the beginning of the journey, you put your leg on the acceleration pedal or gas pedal because you want to increase your speed. Okay, on the middle, normally you maintain your leg on the gas pedal to overcome the friction a little bit, but you are not pushing it as aggressive when you are starting your journey. And when you are getting near to the destination, you will start braking. It means that you are accelerating on the negative direction. So this is exactly what is happening. Okay, so this one is a motion profile. So if you understand how the velocity and the acceleration work, the position is very simple. At the beginning, when your speed is slow, okay, the changes in your position is also small. Okay, it means that it has a little bit of a slope in this direction. It means that it is not a straight line. And when you are reaching to the destination, you are reducing down your speed, right? So on that side also, your slope it's changing. Okay, the direction of your slope is changing. It means that the rate of changing position is changing. So you will see that the slope it become like that. So why we need this? Okay, so why we need this one in the robotic application? So like exactly like when you're doing it, this one in a highway, okay. When we do robotic also we have limitation. Okay, in highway also you have limitation, right? So for example, in a highway, you cannot to go more than 120 kilometer per hour. So in the robotic application also is like that. For example, you have a linear guide or whatsoever. So they will determine to you that, for example, the maximum speed that you can run this system is, for example, 1 meter per second. Okay. So you have not to violate that. So that is the reason that you have to limit the speed. This is one thing. For example, acceleration. Okay? So your motor has a limited torque. Okay. What does it mean? It means that the amount of the power that your motor can produce, it is limited. You cannot to put infinite, for example, acceleration into your motor. Okay, so it doesn't have enough torque for that. So you have to limit the acceleration also. So this is the reason that, for example, you see here and there. What are the limitations? So let's So bearing velocity, for example, if you have a linear guide, for example, your bearing has, for example, say that, for example, the maximum that this linear guide can handle is, for example, 100 meter per second. And that is something imaginary. No linear guide can handle that. Okay, that is not. I have never experienced with something like that. Or for example, your coupling velocity. Okay, so for example, for coupling, you need to connect, for example, your motor to the linear guide, right? So let me show you what is, for example, linear guide first. Okay, so this one is a linear guide. So when they want to turn the motor, they need these things. When, for example, they want to achieve a linear movement, they need these things. So let me show you which servo. Yeah, so okay, so when, for example, they want to do a linear motion, they have something like this. Or for example, you have couplings like this to connect your motor to, for example, your, for example, wheel or whatsoever. Okay, so for robotic stuff, you need to have these things. So to, for example, transfer the, for example, the power from one thing to another thing. Okay, so these guys, they have limitation. You cannot to put as much as a speed or velocity or acceleration or whatsoever torque into them. Okay, they will break. Okay, so they will get damaged. So you need to limit these things. Okay, so and beside that also, you won't have a smooth motion. Okay, so if, for example, you do imagine if you want to move something delicate. Okay, a smooth motion is matter. So a smooth motion also is important, right? So for example, if you go, for example, imagine you are moving something delicate. Okay, for example, you are, for example, moving something like a wafer. Okay, let me show you a wafer. So imagine some case scenario like somebody give you a wafer, and after that they ask you to, for example, transfer this thing from one location to another location. This is a typical machine that you see in semiconductor manufacturing. Okay, so I'm from Semico. Okay, so they will ask you to move a wafer from, for example, from this location to another location. Okay, so this one is some motion. The movement for this one supposed to be very how to say that, smooth. Okay? So you cannot to just take the wafer and after that move it very fast, because this thing is very fragile. So you have to have a very smooth motion. So that is the reason that you need motion profile. So motion profile is a must. Okay, I just tell you like this. Okay, all the robotic stuff that you see, they have a motion profile. But just I'm trying to tell you why you need this in the first place. Okay, so why this is a necessity. Okay, and I'm doing exaggeration. So something like a wafer machine. This one is something more, how to say that, more advanced than that. If, for example, there is no, for example, something like a motion profile, you will definitely die. Okay, so this one was the first part. Okay, so